Hello students, and welcome back to the next module of 3D lines. Here we are going to solve some problems by sitting down. The heading says problems on shortest distance between the lines. Yeah, let us start. The first question says find the shortest distance between lines x minus 1 upon 2 equals to y minus 2 upon 3 equals to z minus 3 upon 4 and x minus 2 upon 3 equal to y minus 4 upon 4 equal to z minus 5 upon 5. Alright students, so Cartesian equations are given, we need shortest distance. Let us start. In solution, the given lines we copy x minus 1 upon 2 equal to y minus 2 upon 3 equal to z minus 3 upon 4. Right students? Now let us call this equation 1. And the second line is x minus 2 upon 3 equal to y minus 4 upon 4 equals to z minus 5 upon 5. Let us call this equation 2. Now students, from these lines we can get points on the line, that is x1, y1 and z1. That is x1 is 1, y1 is 2 and z1 is 3. Similarly, we can get direction ratios a1, b1, c1. a1 is 2, b1 is 3 and c1 is 4. This is data obtained from line 1. Similarly, from line 2, x2 is 2, y2 is 4, z2 is 5. A2 is 3, B2 is 4 and C2 is 5. Now once we have this data collected students, now we can go for shortest distance as a magnitude, that is mod. Under mod we have a determinant of x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1 and a2, b2, c2. The denominator says square root of b1 c2 minus b2 c1 the whole square plus c1 a2 minus c2 a1 the whole square plus a1 b2 minus a2 b1 the whole square. Now students, we have all these values available. If we put it here, we get the shortest distance, but we will calculate them in parts. So we will calculate numerator first. Numerator is x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2. And this becomes, for our problem, it gives 1, 2, 2 as the first row, 2, 3, 4 and 3, 4, 5. On simplification, we get 1 into 15 minus 16 minus 2 into 10 minus 12 plus 2 into 8 minus 9. And this becomes minus 1 plus 4 minus 2 and that gives 1. So the shortest distance required is 1. Alright, and now the denominator part is this students. When we put the values here, we get 15 minus 16 the whole square plus 12 minus 10 the whole square plus 8 minus 9 the whole square. Now if we simplify this further, we get 1 plus 4 plus 1, that is 6. Now the shortest distance between the lines 1 and 2, that is given lines, will be mod of numerator is 1 and denominator is square root of 6. Alright, so here we get the shortest distance as 1 upon root 6 units. Alright students, so here we complete question number 1. Let us proceed. Question number 2 says, if the lines x minus 1 upon 2 equal to y plus 1 upon 3 equals to z minus 1 upon 4 and x minus 3 upon 1 equal to y minus k upon 2 equal to z upon 1 intersect each other, then find the value of k. Now students, in this question, the two lines are intersecting. Yeah, you remember the condition? Let us proceed. X minus 1 upon 2 equals to y plus 1 upon 3 equal to z minus 1 upon 4. We compare this line with the standard form x minus x1 upon a1, y minus y1 upon b1, z minus z1 upon c1. And on comparison, we get x1 is 1, y1 is minus 1, z1 is 1. Similarly, we get a1, b1, c1 as 2, 3, 4. Alright students, similarly, when we compare the second line, that is this equation, with the standard form x minus x2 upon a2 equal to y minus y2 upon b2 equal to z minus z2 upon c2, we get x2 as 3, y2 as k and z2 as 0. Similarly, a2 is 1, b2 is 2 and c2 is 1. Now students, as the lines are intersecting, the condition is determinant x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1 and a2, b2, c2, this determinant value has to be 0. right students? So when we put values here, we can get value of k, and therefore the determinant 2k plus 1 minus 1, 2, 3, 4 and 1 to 1, this value of determinant is 0. On simplification, we get 2 into 3 minus 8 minus k plus 1 into 2 minus 4 minus 1 into 4 minus 3 equal to 0. This gives minus 10 plus 2k plus 2 minus 1 is equal to 0, and that means 2k minus 9 is 0. This gives value of k as 9 upon 2. Alright students, so here we learned some more problems on shortest distance between lines. Thank you.